Okay, so this is a 2013 paper. It's paper 2, and the topic that we're working on here is probability. So, first question starts off. It says, Katie tossed a coin 200 times and threw 109 heads. Joe tossed, now it's important that they say the same coin, he tossed it 400 times and threw 238, and Lucy then took the same coin 500 times and threw 291 heads. They think that the coin may be biased. Give a reason why they think that the coin may be biased. Now remember, when they talk about reasons, they really mean mathematical. So what we're really going to look at here is what's the probability based on the numbers that we see. What's the probability? So if we take a look, there was of all of the times that it was thrown, there was 200. This is all of the times that was thrown: 200, 400, and 500. So it was thrown a total of 1,100 times. Of those times, a head was thrown 109, 238, 291 times. When you add that up, that gives you 638, which means the probability based on their experiment, the probability of a head is equal to 638 divided by 1100. And if you convert that into a decimal, you'll get 0.58. So because the probability of getting a head, what we would expect in theoretical probability, we would expect that the probability of getting the head should be 0.5, but because they're getting a probability of 0.58, that's why they're saying they think the coin may be biased. So you might just want to write something in there. Therefore, you might want to write a sentence to that effect, or just therefore. Therefore, they think the coin is biased. Okay, so moving along, it says Lucy uses the above data, and it says all the above data, and calculates that the best estimate of the probability of throwing a head is 0.58. Show how Lucy might have calculated this probability. Well, in actual fact, if you take a look just here, this 0.58, we've already calculated the 0.58. So we've already shown that. What's really important is that even though you've written it all out in part A, if you don't write it down for part B, you will not get the marks. So they won't look at part A and say yeah, that's fine. They clearly knew what was going on. You must write all of your information. So again, your 109 plus 238 plus 291 equals 638 out of 1100, and show that that's equal to 0.58. I think given the question, it would probably be worthwhile, seeing as this is what you've been asked to do, it would probably be worthwhile bulking out this sentence or this explanation here. So the last part of the question says, Joe agrees with Lucy's estimate of 0.58 of throwing a head. So he's saying that it's 0.58 for a head. He claims, though, the probability of throwing 3 successive heads is less than the probability of throwing 2 successive tails. So that's the probability of a head, and a head versus the probability of 2 successive tails, so a tail and a tail. And we're being asked, calculate the probability of each event, which we will do, and then state whether or not you think Joe is right. So if you just take this portion here, let's go head. It's a head and a head and a head. So the word that I think is important, and I've said to you guys, is this word here, and. And means multiply. So the probability of getting a head is 0.58 and another one is 0.58, and means multiply another one 0.58. You pop that into your calculators, you're going to get 0.195. So versus the probability of a tail and a tail. Now before you can calculate the tail and the tail, you have to do a little calculation over here. I'll put it in pen so it's a little bit smaller. If the probability of getting a head is 0.58, well then the probability of getting a tail is 1 minus 0.58, so that's 0.42. So now we can go back, probability of a tail, so remember that's tail, and means multiply. So we're going to say 0.42 multiplied by 0.42. Into your calculators, that will be 0.176. So we've answered the first part of the question where it says calculate the probability of each event. But now we have to state whether Joe's claim is true. So let's just check what Joe claimed. He claims that the probability of throwing 3 successive heads is less than 2 successive tails. So the question we have to ask is 0.195 less than 0.176? It isn't. So we have to say whether Joe's claim is true or not. Joe's claim is not true.